Alright, you're finishing up your bell ringer. You've got your study guide out ready to go. Test is tomorrow. Okay, test is tomorrow. So first one we're looking at on number 1. It says a parabola has an axis of symmetry at x equals -2. And it passes through the point -5, 6. And it asks you to find another point that's on the parabola. There are lots of other points on the parabola. Okay, a parabola, just like a line, goes forever. So there are tons of other points you can list. But this is intended, it's set up for you to find one pretty stinking easy. Okay, and a lot of people thought this was a confusing question because you didn't think of the graph. When I was showing somebody on Friday how to do it and I started drawing the graph, they said, well, you don't have to draw a graph. Correct, you don't, but it shows you another point, super duper easy, if you will. So I'm going to move over to x equals -2, 1, 2. There's my axis of symmetry. That's where my fold line is. Okay, then I got my other point, -5, 6. So I'll go left 5, 1, 2, 3, 4, 5, and up 6. 1, 2, 3, 4, 5, 6. And all I need to do to get another point is do my fold on the axis of symmetry. So if I said, well, this point is 1, 2, 3 away to get right there. So I would need to go 1, 2, 3 away to get on the other side. Where did I land on that point? Well, it's over 1 and it's still up 6. That's exactly right, Hunter. Good job, good job, good job. It's good common sense thinking. I like it a lot. Okay. All right, number 2. Good job. Number 2, we've got f of x is equal to x squared minus 3. Okay, you got it? You with us, Grant? It says let the graph of g be a vertical stretch by a factor of 4. So I've got to have g of x, and I've got to vertically stretch this by 4. Shrink and stretch means multiply or divide. So I'm going to be multiplying by 4. Vertical goes in front of the whole thing. So if I just rewrite this here with a 4 and then an x squared minus 3, that makes it look like the 4 is only on the x, doesn't it? So what could I add that would show it's in front of the whole thing? Very good, Hunter. To show it's in front of the whole thing, I'm going to do that. So I've got my vertical stretch of 4. Then it says a reflection on the x-axis. Reflect the x-axis. Reflect always means negative. X-axis is in front of the whole thing. So that 4 that's already in front of the whole thing now gets to grab my negative. That's correct. Okay, you could leave your answer there. Anybody know another way you could write that answer?
-4x squared minus 5.
Would that be the same thing?
Yes.
If you distributed that -4? That's actually considered a more standard form of an answer, but I don't like it as much because the first answer this way, it describes the transformation better. So if it were me on my test, I would have stopped here. But if you went ahead and distributed, it's correct as well. Okay, okay, okay. Number 3, we've got f of x is equal to the absolute value of x minus 4 plus 2. Okay, so this one says, let the graph of g be a translation of 1 unit down. So I'm going to start g of x. To take something up or down, it sticks on the end. So I already have a plus 2 stuck on the end, and it told me I want to take that 1 down. 1 down will be minus 1. So that's going to change. Plus 2 minus 1 is going to change that to a plus 1 on the end, isn't it? Okay. Next it says, and 3 left. Left and right gets added in with the x, and it goes the opposite way of the sign. So 3 left would mean a plus 3. Already got a minus 4 in there. So that minus 4 plus 3 would make that be minus 1. And that's it on that one. How we doing so far? So far, so good. Okay, on number 4, as soon as you read the word focus, you need to get that 1/4 P stuff in your brain and go find your 1/4 P notes. Anytime it says focus, you've got to make that connection. It's the 1/4 P notes. Okay, so it tells me on number 4 that I've got f of x is 1/16x squared. This is a normal U parabola. I know that because f of x is the same as y, so I've got y equals x squared. It's positive, so it's opening up. So I'm looking for y equals 1/4 px squared. I just have to figure out 4 times what gets me that 16. And that's an easy one. My p's got to be 4. So now I just use that to fill in the blanks about my focus and directrix. Okay, if I'm a parabola that's opening up, my focus would have to be up there. So my focus would be 0, 4. My directrix would have to be down here. So my directrix would be x equals -4. I said that wrong. Did y'all catch that? No? Why is it not x equals? Very good. I moved down to get to it. Up and down is y. So it'll be y equals -4. What else did it ask for on this? Axis of symmetry. So my axis of symmetry would be that y-axis. I can't get it on there. So I could write out y-axis. That's the same as saying x equals 0. Okay, on 5 and 15, 5 and 15 both, we were supposed to look at those tables that same day we did the word problems when we were shooting, I think it was Garrett, when we kept shooting Garrett out of the cannon, but we ran out of time and didn't get to the tables. So I'm not going to make you do those completely on the test, but I am going to show you something so you can do a little bit of it. And I'll make the same adjustment on the test tomorrow, but you do need to see one thing I'm fixing to show you. So on number 5, still got a couple people writing here, and I'll draw my table for number 5. All right, we got an x and a y, so an input-output table. We got 1, 2, 3, 4, 5 on your x's. Grant, I'm worried about you being able to pay attention there. Then we got -2, 2, 10, 22. And 38. All right, so it says explain why a quadratic function models that table. So explain how we could figure out based on that table alone that this is a quadratic. And I'm going to do that part with you, and that's all you'll be responsible for on the test tomorrow. You are looking at patterns here. Okay, so if I went to my y's from -2 to 2, I would have an increase of 4. From 2 to 10, I would have an increase of 8. Boy, this is a good Monday. From 10 to 22, I would have an increase of 12. And from 22 to 38, I would increase 16. Okay? Now, I call that the first level. That first level of differences, there is a pattern. This one went up 4, this one up, that's right. But it's not a consistent difference. If this had been a consistent, like if these had all been +4, +4, +4, +4, that would mean this table is linear. It would make a line. But my first level did not have a consistent difference, so it's not linear. What power is a quadratic 2? What's the highest power on a quadratic? Squared. It's the second power, right? So to check to see if this is a quadratic, you got to go to your second level. So here's my first level. So now I'm going to see what the difference between those is. And you know it. From 4 to 8, we gained 4. From 8 to 12, we gained 4. From 12 to 16, we gained 4. Winner, winner, chicken dinner, those are all the same. So the reason we would write for how we know it's a quadratic is the second level of differences is the same.
So to make it linear, it has to be like +4, +4, +4.
Yes, the first level would have to be the same. Yes. Okay, and then it says use the linear to write the equation. We're not going to get that deep into that today. Use the system. Okay, on 6 through 10, I still have it up there by Paul on that board. I told you you could just choose one. And this is what I want to guide y'all to do on your test tomorrow. Choose the one that the vertex is at the origin, because those are the ones we did in class. They're a lot easier. We can do number 6, but number 6 is vertex has been scooted up to, so we would have to account on our equation for that translation. So let's just pick one where we don't have to translate it and stick on that. So look at number 7, right? 7, it is sideways, and those are not as common, but it's sideways at the origin. So we got a parabola there, and that vertex. It's hard to read on that graph, but it is at the origin. The directrix is over here at x equals 3, isn't it? Are you looking on number 7? Now, they don't plot the focus because their graph ran out of room, but the focus, if you were asked, would be at -3, 0, wouldn't it? All right, so we've got to write an equation for this. It's a sideways one, and it's pointing to the left. So it's going to be x equals -1/4p y squared. Now, what I had to know, I started with the 1/4 stuff because it's a focus and directrix question. I knew it was x equals y squared because it was left and right. It's pointed sideways. And I know it's going to be a negative because it's pointed to the left. So all I have to do now is plug my 3, because I know it's a 3 based on my focus and directrix, right? Plug my 3 in for the p. 4 times 3. So my equation here is just x equals -1/12 y squared. And that's it. So we don't have to worry about scooting it or reflecting or shrinking or stretching, which you do on some of those other ones. Okay. Well, my camera got jostled. Are you jostling the table, Bradley? Jeez.
Wait, so how do we watch these?
It's on YouTube. I told y'all that. So,
What do you look up though?
it's on my page, which is Lynne Wright, Lynnea.
Say that again.
Lynnea.
I got that. Thank you, Ms. Ross.
You're welcome. And there's Algebra 2 2019-2020 playlist. Numero 10. Got another sideways one here. X equals -1/2 y squared. It asks for the focus, the directrix, and the axis of symmetry, and they provide you a little graph down there if you need it. Okay, since this is x equals and it's negative, I know it's going to be opening just like the last one that we did to the left. Okay, so I got to figure out what I could plug into the p that when I times it by 4 gets me 2. So 4 times what is 2? Right? It's a half. Everybody with me on that? Good, Garrett. So my p is either 0.5 or a half, whichever way you want to write it. Same difference. So we know that focus now would have to be inside. We talked about the definition of focus. It's inside the parabola. So to get there, I would move left first. So it would be -1/2 or 0.5 if you write it like Garrett said, 0. My directrix would have to be over here. So to get there, I would move right. So that's x equals a half. Now the axis of symmetry on this dude is on this axis this time, the x-axis. So you could write x-axis, which is the same as y equals 0. So let me caution you on where it's going to be real easy to get this wrong. If I put the directrix is y equals a half, that's wrong. Because y equals a half means you would move up a half, and that line would be like that. So you've got to pay real careful attention on your notes about which way it's facing and what variables, if it's the x or the y. Okay, because those change around on that. Remember that note we copied that day with the 4 sections? Those x's and y's change around. Alright, we're flipping the page when you get that one done. We're rocking and rolling. Rocking and rolling. What shows that off of? Okay, great talk.
What was the talk?
I want to say Greece, but I'm not positive. Alright, on 11, a bridge builder is constructing a cable suspension bridge in our town. Boy, wouldn't that be exciting? A suspension bridge in Haskell. The cable being used will form the curve modeled by, here we go, h of x is equal to 3x squared minus 6x plus 200. Where x represents the length of the cable used in feet and h of x represents the height of the cable. At what height will the cable hang closest to the bridge deck? So you don't have to be able to visualize this here, but I like to. I'm a visual person. So what this would look like, it's a parabola that's opening up because your A is positive. So here would be your ends to your bridge. So they are going to suspend cables from there. So that would be what you're dealing with. So we would be driving down here, and this thing would be hanging up there on the tops of that bridge. So that's what you're dealing with. All right, so it asks, the question says, at what height will the cable hang closest to the bridge deck? Well, that would be right there on the axis of symmetry, or the min value, right? So if I can basically find the vertex here, my answer will be that minimum value. So what form is this parabola given to me in? Standard, intercept, or vertex? Standard, so I'm going to start by doing negative b over 2a. So I would have negative 6 is my b, over 2 times 3 is my a. Now that negative times a negative is a positive, so 6 divided by 6 is 1. So I know when I've moved 1 over to the left is when it's the lowest, so I just need to plug that 1 in up there for the x's now and solve. So 3 times 1 squared minus 6 times 1 plus 200. 1 squared is 1, 3 is 3. 3 minus 6 is negative 3, so I got negative 3 plus 200. Well, that's 197 feet. So on my picture that I drew there, it makes it look like the road is pretty close to that hanging cable. But in reality, we just found out it's 197 feet away from that hanging cable. So you don't got to worry about it hitting you in the head.
Will we be able to use our notes in the test?
You bet your boots.
Thank you, Ms. Rice.
You're welcome, Mr. Witherspoon.
I'm going to need it.
You don't take a lot of them, though, is what I'm thinking. You're going to get some for tomorrow, though, right?
Oh, I've actually got the notes in.
Okay, good. Good in the hood. Alrighty, number 12. And draw a little. No, I can just get a piece of graph paper right quick. Alright, so here on number 12, it tells us to graph that. It asks us to label the vertex and the axis of symmetry. And then it asks us to describe where the function is increasing or decreasing. They only give you 2 little blanks over there. So I'm going to put my vertex and axis of symmetry on the graph. And then I'll put on the blanks over there where it's increasing or decreasing. But if we counted up points here, graph, vertex, axis of symmetry, increasing or decreasing, number 12 is worth 5 points. So we got to make sure we read the directions and get them all. All right. Do you realize what form that equation they gave you is in? Intercept, vertex, or standard? Very good. It's in vertex. So that means it tells us our vertex. HK, the opposite on your H. So negative 1, negative 3. So very good. I'm going to go left 1 and down. Whoops, left 1 and down 3. 1, 1, 2. Scoot some up. 2, 3. So there's my vertex. And to make sure I get all my credit here, it said label it. So I'm putting it on there. Okay. It also said to label that axis of symmetry. So when I get my dotted line dotted through there, I'm going to find somewhere to label it. Okay, don't miss those easy points.
Wait, why would that be negative?
You do the opposite.
When it's in vertex form, the one with, well, it won't scoot for me good, Garrett. When it's in vertex form, the one with the X is always the opposite. So +1, you do a -1. Alright, so now we just need to find another point. So this is when you get to pick one to plug in for the X. Okay, I could do 2, but that's kind of way far away from my axis of symmetry. So I want to pick one closer to -1. 0 would be okay. And Garrett would not be wrong if he did 2. It would just be a higher point for me to graph. So if I plug 0 in, 0 plus 1 is 1. 1 squared is 1. 1 times 3 is 3. So you just end up with 3 minus 3. Well, wasn't that nice? We got a 0, 0.
Just count over.
And then right, Grant, we just count that over. So let me scroll down so I can find my other point to draw that pretty parabola. Fancy. Flip-flops, yeah.
Wait, so 0 is
I picked 0 as just another random point, and when I plugged it in, it got me a 0. We're not done. That's only 3 answers. We've got the graph, the axis of symmetry, and the vertex. Now it asks for increasing and decreasing. When we talked about this in class, this was the problems I told you when I was riding my bike. So if I get on the left side of that graph and I start riding my bike, I'm going downhill quick. So I am decreasing everywhere on the left side of that axis of symmetry. That axis of symmetry is -1. Left side of -1 would mean
Decreasing.
less than -1. Bless me. Thank you. That was funny. I normally wouldn't say that. All right. Then when I hit -1, I start riding uphill, which means I'm increasing. And I'm increasing on the right side, which means X is greater. Good job. Woohoo! Now, when we get to 13 next, it's in standard form. Mr. Cross is correct, and we got to answer the same 5 questions. Graph, vertex, axis of symmetry, and increasing and decreasing. So we still need a minute here on this one. We ready, Freddie? All right. We are starting on 13 right now. Are you good, Manny? What can I help you on? Okay. This is so assuring. All right, Grant said this number 13 is in standard form, and he's correcting me. No, it is. So what we do in standard form, and you need to make sure you've got a note. Shh. You need to make sure you've got a note, and you know when we're in standard form, we're always going to begin with -b over 2a. Always standard form -b over 2a. That will tell me the axis of symmetry, and then I just take that value and plug it back in to get my min or my max. Okay, so I always write the negative. Some of y'all skip that step, and that's fabulous. Negative, and my b is -4. Over 2 times -2. Good. Now look at, is my result here going to be a positive or a negative?
A positive, because there's 2 negatives.
There's 3 negatives.
Ooh.
So
it's a
I go,
negative.
Good. I go here, negative up by negative is a positive, but then that other negative will turn it back to a negative. So my x is going to be a negative. 4 divided by 4 is 1, so I got -1 for my axis of symmetry. Okay, now I'm going to plug that back in. Okay, -1 squared is 1. 1 times -2 is -2.
Would it be positive?
The first part would, yes. Negative 1 squared would be positive 1, but then when you times it by negative 2, it would turn it back to negative. Negative 4 times negative 1 is positive 4. So that is 2 plus 3. So I've got a vertex at negative 1, 5. So I'm going to go left 1 and up 1, 2, 3, 4, 5. Make sure and label it because the direction's said to. That axis of symmetries, I drop that down through there. Make sure and label that because the direction's said to.
So it's going to open now.
Yes, it's going to open down. Our A is negative. Good job.
Over negative 1 is that?
So let's
Yes.
put 0 back in.
Okay, if I put 0 back in, I'm with Grant. I like that. If I put 0 back in, that would go away. That would go away.
3.
All I'd have left is 3. So over 0, 1, 2, 3. And then count that to the other side of your axis of symmetry. And there is a beautiful parabola.
Wait, so you
So
go over
it's
1
increasing.
and... I'm sorry.
Where is that?
I plugged a 0 in.
Yeah. I think I missed. Oh, I'm missing the 5. That's right.
Okay. All right, we still need 2 more answers. Don't leave this problem yet.
Oh,
Increasing and decreasing. If I get on the left side of that graph, I'm riding uphill first. So I'll be increasing on the left side of the axis of symmetry. And that means less than negative 1 if I'm on the left.
dang.
Then I'll start decreasing on the right side of negative 1. The right side is greater.
So it's a 50-50 shot of getting it right.
Yeah, I reckon so. Bless you, bless you.
I'll be that one.
Garrett's going to get it back and win this.
So I usually do win the test.
Win the test. Get on all the assignments and win the test.
That's usually what I do.
Okay, we ready for 14? 14. We got a funny picture there with a microphone. It says at a recent sporting event, you notice the microphone being used to record the sounds. A drawing of the microphone is shown. The microphone is placed 8 inches away from the reflector at the focus of the parabola to collect sound. Push pause. I underline focus. So this thing is pointing to the right. You should see a parabola pointing to the right. Left and right is x equals, not 14, dumb butt.
Wait. It'd be 8, wouldn't it?
Just let me show you though, but you're right. X equals 1 over 4p times y squared. Okay, and the reason I wrote that and I underlined it on my test was because it said focus. Okay, the focus of the parabola to collect sound. Then it says write an equation that represents the cross section of the parabolic reflector, assuming the vertex is at the origin and it opens right as shown. Alright, so in the picture they told you the p. That's what Garrett just pointed out. Your p in that picture is the 8. So all you have to do to finish this dude out is 4 times 8. So your equation, see that's something that easy. Knowing what 4 times 8 is got you the answer. But a lot of people will read that and think they don't know what to do and quit.
Wait, so how did you get the 8? I just looked in the problem.
Yeah, and that was that distance from the vertex to the focus. So the distance from the vertex to the focus was 8. That'd be like saying the focus was 8, 0. That 32 is easy to read. That's one of my better 32. So why can't y'all read that? Come on now. My 0 have a line to 100. Come on. I'm just picking on you. Alright, one more on 15. It's a table, but we are going to be able to get the answer for this. And I bet if y'all tried, several of y'all probably did get it. Did anybody try it? I know it was. What'd you get?
Same thing we did on number.
Not exactly.
Right.
What'd you get?
36.
That you need to make one adjustment, but that's right.
Oh.
Fabulous, Bradley.
Good job,
Good.
Bradley.
How do you?
Screaming at the camera because I gotta listen to that right.
Alright, so here's the table.
Oh, I see.
Here's the table that we got here. It says it shows the number of toy bears a toy manufacturer can sell. So X is the price in dollars, and here's all Bradley needs to do to his answers. The Y is the bears sold in thousands. So that 36 is right, Bradley, then you just need to make it thousands. Alright, so it says use a quadratic regression to determine how many bears the manufacturer will sell if it charges $9 for each bear. Well, our table goes to $7 for each bear. So we just got to extend that table out to get to $9. Okay, so you should see the vertex. Here's your vertex, right? Because look on both sides. There's the 96, there's the 84. So from 84 to 96, what happened?
You went up 12.
Okay, from 96 to 100, what happened?
You went up 4.
Went up 4. From 100 to 96.
You went down 4.
From 96 to 84.
You went down 12.
Okay, now some of you can tell what the next number is going to do, but check this out. Remember I talked about second levels earlier? There's a down 8. There's a down 8. There's a down 8. So my next one would have to be a down 8. So if I'm at negative 12, what would go in this blank that's down 8?
20. Negative 20.
Negative 20. So that means from 84, I would have to take 20 off.
It's 64.
Okay. Now I'm at negative 20, and I got to go down another 8.
That'd be negative 28.
So that'd be negative 28. So what would 64 minus 28 be?
36.
36, like Bradley said. And then take that to your the graph says that's in thousands. So if they charge $9 a bear, they're going to make 36. They're going to sell 36,000 bears. So fabuloso job.
I just got confused.
Okay.
What is the number say that's
Oh,
Negative 20.
Where did you get the number?
Okay. I went.
The 8.
Yeah, I went down to see what if I did negative 12 minus 8 to get. It would have, you know, that was a lot of mumble jumble, but I think you get it. Right?
I got what you said.
He talks all the time. No, I want to try to say something about you can ask her. I'll just be like, just say stop. Rewind.
Alright, you will tomorrow be able to use notes. Your study guide can count as your notes if you need it, if you wanted to. Feel better today than you did Friday? I saw a lot of yeses. I saw a lot of yeses. No, you're not going to fail. Okay. After we finish the test, then on Wednesday, I've got a quadratic project that we're going to start. Woohoo!
I think we should have like a celebration. Oh wait, do we have?
If we